Hello everyone. In today's topic, we are going to talk about possibility space. So the objective of this lesson is to find sample space using a grid, a tree diagram, and a list. The relevance of this topic is to learn various methods of finding out how many possible outcomes of a probability experiment are possible, and use this information to find probability. So let us have some definitions. So outcome is a particular result of an experiment. Event is any subset of all outcomes. So this is also called the sample space. And sample space, the set of all possible outcomes. Outcomes cannot overlap. All outcomes must be represented. Can find by a list, a tree diagram, or a grid. So let us have an example. List the sample space for drawing one card from a deck of cards. So in here, we all know that we have four different suits when we are talking of that deck of cards. So the clubs, the diamonds, the hearts, and the spades. Under the clubs, we have 2, 3, the number cards, 2 to 9, or 2 to 10, I should say. And then we have the picture cards, Jack, Queen, King, and we also have the ace. So under the diamonds, the same. We have 13 outcomes. So 13 times 1, 2, 3, 4. So the sample space for drawing one card from a deck of cards is 52 outcomes. Now let us have another one. We are going to find the sample space for rolling two dice. So we all know that in rolling one die, we have 6 possible outcomes. So how about if we are going to roll two dice? So the possible outcomes are here. So we have 1, 1 up to 6, 6. So counting this one, 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. So 6 times 6. So the sample space for rolling two dice are 36 outcomes. Now, let us have a question from rolling two dice. So what is the probability of getting at least 1 6? So from our grid, so let us count. It says here at least 1 6. So we can see 6 in the different combinations. So 1, 2, 3, 4, 5, 6. So we included 6 6 because it says here at least 1 6. So it doesn't matter if there are two. So we have 6. So 2, 4, 6, 7, 8, 9, 10, 11. So from here, we have 11 over 36. So over the total number of outcomes. So it is 11 over 36. The probability of getting at least 1 6 when we roll two dice. Now let us have another one. Find the sample space for the gender of children if a family has 3 children. So talking of gender, so it's either a boy or a girl. So see if you can list all the possible outcomes or the possibilities. So from here, if we are going to list it, we have 3B, 3 boys, 2B, 2 boys, 1 girl, 1 boy, 1 girl, and another boy. So 1 boy, 2 girls, 1 girl, 2 boys, and then 1 girl, 1 boy, and another girl, 2 girls and 1 boy, 3 girls for the last listing. So in total, we have 8 outcomes. Then later on, we shall have the tree diagram for that particular problem. So what is tree diagram? Tree diagram is a device used to list all possibilities in a systematic way. So each branch lists the choices. So let's do the tree diagram of the previous example with the gender of 3 children. So remember, we had 8 outcomes. So going back to the problem that we have about the 3 children, and the possible combination of the gender. So this is the tree diagram of that particular problem, and we are going to answer the question, what is the probability of having two boys in the family? As you can see here, we have 8 outcomes. So let us have the combination girl, then boy. So two boys. And then another one, boy, boy, and girl. So two boys. And then another one, boy, girl, boy. So we have three. So from here, so it is 3 over 8. So the probability of having two boys in the family is 3 over 8, according to the tree diagram. Now, so let us display the sample space using a tree diagram if a coin is tossed and a die is rolled. So it's a combination of two experiment here. So from here, as you can see, we have the head and the tail for the coin and 1 to 6 for the die. So we have 12 possible outcomes. So H1, H2, H3, H4, H5, H6, T1 up to T6. So we have 12. So what is the probability of having a tail and an even number? So the even numbers from 1 to 6 are 2, 4, 6. So take a look at the T. So we have 1, 2, and 3. So therefore, 3 over 12, or in lowest term, we have 1/4, dividing both the numerator and the denominator by 3. Now let us have another one. Let us draw a tree diagram if you toss one coin and spin 4-section spinner. So in our tree diagram, for the coin, we have head and the tail, and for the spinner, we have 1 to 4. So we have 8 outcomes. So H1, H2, H3, H4, T1, T2, T3, T4. So let us answer the question, what is the probability of having a head and an odd number? So in here, concentrate on your H because head and an odd number, the odd numbers from 1 to 4 are 1 and 3. So the first odd number, 1. And then in here, let us count. So 1 head, an odd number, and 1 head, another odd number. So we have 2 over 8, or in lowest term, dividing both the numerator and the denominator by 2, it is equal to 1/4. Now let us have another one. A lunch menu has a choice of the following, one from each category: the meat, hamburger, hot dog, chicken. Then starch, the French fries, the FF later on, and BP, the baked potato. And for the drink, we have Coke and tea. We are going to list all the possible combinations. So using the tree diagram, we shall have the sample space for this particular scenario. So according to our tree diagram, we have 12 outcomes. So we have the meat, hamburger, hot dog, chicken, and we have the starch, FF, French fries, baked potato. And for the drinks, we have the Coke and the tea. So let us count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So really, we have 12 outcomes. Now let us have the last example. A fair coin is spun twice. So this is for the first coin, head and the tail, and for the second coin, we have from H branches head and tail, and from tail branches head and tail. So how many possible outcomes do we have, or sample space? So from here, let us list 2 heads, 1 head, 1 tail, 1 tail, 1 head, and 2 tails. So we have 4 possible outcomes, or the sample space for a fair coin is spun twice are 4. So 2 heads, 1 head, 1 tail, 1 tail, 1 head, and 2 tails. So that's it for now. Please do your worksheet number 4 in your Google Classroom. See you again next time. Bye.